Okay, in this section we're going to focus on making predictions using the linear models we found in the prior sections, now that we know that they're valid. Okay, so the big thing I want to point out about making predictions is interpolation versus extrapolation, right? We talked about this before. If you do a data set and you sample all the 20 and 30-year-olds, right, and you figure out their healthcare costs, right, I can't make predictions for a 5-year-old or an 80-year-old. Those are way outside the domain of the samples that I collected. So any model that I make on this data, it's not fair to make predictions about the healthcare costs of these groups that are not part of this group. That would be extrapolation. So interpolation would be within the data group. Extrapolation would be outside of the data group. So it's not proper to do extrapolation, basically. So the first thing is not only following the guidelines, but is the car revenue data okay to use that model? Well, we already did the inference in the prior section, right? We drew the t-curve and did all that, and it showed there is a significant likelihood of a linear model. So we can, in fact, use it to make a prediction, okay? And the same thing with the grade absence problem. Since we did the inference, we should use the model, right? If you do the inference and it doesn't, then you should not use the model. So for the teacher-pupil problem, we actually ran into a few problems, didn't we? In the teacher-pupil problem, not only did it fail the inference, but it also didn't even look linear on the scatter plot. So it failed the guidelines and it's failed the significance testing too when we did the hypothesis test. Okay. All right. So the first one is let's use it to the car revenue data to determine the revenue for 150,000 cars. Okay. So go to here and we'll do we'll just merge this together. 150,000 cars prediction. Okay, so y hat equals, we'll shove that to the right. Nope, that's not to the right. That's the right. Okay, so we'll go to here. We'll go back to the prediction model here. So A plus B times 15. Okay, that's one way to do it. The other way is you can do A equals and B equals. This might be easier for you. Whoops. Okay, shove those to the right and just copy those values over. So when I go to A, click it and hit equals and just drag it down. So there's my A and my B from the previous lessons, right? So I'm going to do A plus B times 15. And you're like, well, it's 150,000. Yeah, but if you remember, it's in tens of thousands of cars, so times 10,000, it's 150,000, right? So this is in billions of dollars, essentially. Okay, so it's okay to make that because the model was valid, so you can use it to actually do the calculations. So you're more than fine, and I would recommend using the variables whole names instead of just x and y essentially. Okay, the next problem is what if I'm going to plug in $3 billion in revenue? Well, that's a problem because the revenue is the predictor. You can do it, you'll get a close enough answer, but it's not good. You really shouldn't do it. What you really should do is just remake the model the other way with the variables inversed and not use it this way. You can by plugging in solving algebraically, but it's not as accurate as if you did it the other way essentially. Okay, so you should only use the predictor models by plugging in for the explanatory variable. You shouldn't be plugging in for the response variable, which is what we're trying to do here. That's not good. You can, but you shouldn't. Okay, so the next one is, what about 30 absences? Interesting. Well, if I look at my data set, absences, where is it here? Here it is. Huh. I don't see, oh, it's right here. I'm sorry, this is the absences, right? 30 absences is way outside the data set. This goes from like 2 to 15. 30 would be way outside the data set. If I did like 10, that's interpolation. That's within the data set, right? 11, anything in there. 5, 6, 7, 8, 9, 10. But 30 is way outside. So would 0 be. 0 and 30 don't make any sense. That's extrapolation. Okay, so you shouldn't be trying to do that, basically. So don't make that prediction. That's extrapolation. Okay. What about 25% grade? Well, yeah, the model is fine, but that's the same problem as we had before. You shouldn't be plugging in for the explanatory variable, okay? Or the response variable, sorry. You shouldn't be doing that. That's the outcome. You shouldn't be doing that. That's the why. Don't do that. You can, but you shouldn't. Okay. The next two, use the teacher-pupil problem to estimate based on 12 teachers, and use the teacher-pupil problem to estimate based on a ratio of 16.0. It doesn't even matter what you're plugging in here. It does not matter what you're plugging in. It does not matter what you're plugging in. Because in both cases, this fails and this fails. Okay? This is not a linear model. We did not find enough evidence to make sure to signify it was actually linear. So you shouldn't do anything. You shouldn't make the equation, right? You shouldn't use the equation to predict anything, right? There's not enough evidence it's linear. Do we know what it is? No. It might be nothing. It might be something that's not linear. But all we know is it's not linear. Don't use it to make a prediction if it fails the inference.